Good day, everyone. In today's class, we are going to be looking at the coordinate geometry. Under this topic, we are going to be looking at the distance or the length between 2 points. So it means that distance and length are the same. So we are going to be looking at the distance between 2 points. But to start with, we are going to be looking at the definition or the meaning of coordinate geometry. So the coordinate geometry simply means the study of the line. So the study of the line, as we know, circle geometry, that is the study of what? Circle. So coordinate geometry is the study of the lines. And under this, we are going to be looking at the distance between 2 points, or the length. Length and the distance between 2 points are the same. So to start with, we are going to have a diagram, which is in form of a graph. So we call this XY plane. So we are going to have a straight line. We are going to have a straight line with point S of coordinate S1, Y1, and we have point T of coordinate S2, Y2. Then on this straight line, we want to know the distance between this point S and point T. So that's what we are looking for. Now we are going to form a right angle triangle. So by having this, we form a right angle triangle. So we form a right angle triangle, and we can name this point R. So we have angle 90 here. So to derive the formula that will give us the distance between 2 points formula. So what we need to do here, we are going to locate point S. Point S is of coordinate S1, Y1. So we trace this one to the x-axis. So this is our x1. And we trace this to the y-axis, which is our y1. Then the second point T is of coordinate S2, that is on the x-axis. Then y2 on the y-axis. So to now know the difference between S and R, we are going to have S2 minus x1. Then to know the distance from R to T, or between R to T, we are going to have y2 minus y1. So where do we go for this? If you check, TR is vertical. That's why we move, the initial point of R, which is y1, then point T is y2. So difference between y2 and y1 is y2 minus y1. Then the same thing for s2 minus s1. So to know the distance between S and T, we are going to make use of Pythagoras theorem. So as you can see, this triangle SRT or STR is a right angle triangle. So you can now say by Pythagoras theorem. So by Pythagoras theorem, and Pythagoras theorem states that the hypotenuse square equals to the adjacent square plus opposite square, or opposite square plus adjacent square. And how do we identify our hypotenuse side? Hypotenuse side is always the side that is angle 90, so which is line ST. So our hypotenuse side, so our hypotenuse squared equals to opposite squared plus adjacent squared. And the hypotenuse squared here is line ST. So ST squared equals to OP. OP is the distance from O to P. That is distance along horizontal axis. That is S2 minus x1 squared. Then plus distance along the vertical axis. That is y2 minus y1 squared. So the next thing to do is to simplify by making ST the subject of formula. And to make ST the subject of formula is to take the square root of both sides. So we are now going to have square root of line ST squared equals to square root of S2 minus x1 squared plus y2 minus y1 squared. So the square root comes to the power of 2, so we are left with line ST, which is equal to square root of S2 minus x1 squared plus y2 minus y1 squared. So this is the distance formula for, this is distance ST formula. So the distance ST formula equals to square root of S2 minus S1 squared plus Y2 minus Y1 squared. And where do we get this S2, S1, Y2, Y1? So we get our S2 from S, which is of coordinate S1, Y1, and T, which is of coordinate S2, Y2. So let's now move to the first example. So the first question says, examples. So the first question says, find the length between the point. Find the length between the point A of coordinate 2, 5 and B of coordinate 5, 9. 5, 9. So we are asked to find the length between these 2 points. So I've told you the length and the distance are the same. So it means we are looking for the distance between A and B. And what is the distance formula? So the distance formula will now be the solution. Or before the solution, we can just say, before we write down the formula, we can say point A is of coordinate S1, Y1, which is equals to A of coordinate 2, 5. So it means S1 is what? 2 and Y1 is 5. Then for the second point B is S2, Y2. So which is of B, which is equals to 5, coordinate 5, 9. Then the distance formula will now be line AB. So which is distance AB equals to square root of S2 minus S1 squared plus Y2 minus Y1 squared. So which is equals to, so let's replace S2, S1, Y2, Y1 with the values given. So S2 is given as 5. So we have square root of 5 minus S1, 2, then squared plus Y2, that's 9, minus Y1, 5, raised to the power of 2. So which is equals to square root of 5 minus 2, that's 3 squared plus 9 minus 2, 9 minus 5, that's 4 squared. So which is equals to 3 squared is 9 plus 4 squared 16. So square root of 9 plus 16, that is 25. Then square root of 25 is 5 units. So we have 5 units because we are dealing with the distance or the length. So we have 5 units. So that is that on example number 1. Example 2 says, if the distance between the points -3, -2, and 1, y is 2 roots 5 units, find the value of y. So here we have incomplete points on the second point given. So we have complete S1, Y1. So our solution is S1, Y1 is given as -3, -2, and S2, Y2 is given as 1, y. So when we are given the distance, so the distance is given as 2 root 5. So what is the distance formula? So distance formula is given as square root of S2 minus S1 squared plus Y2 minus Y1 squared. So distance is given as 2 root 5. So we are going to have 2 root 5 equals to square root of what? Square root of S2 minus S1. So our S2 is 1. So we have 1 minus S1 minus 3. So minus minus 3, then all squared, plus y2, that is y, minus 2, then close another bracket, then square. So the next thing to do is to take the square of both sides. To bring what we are looking for. What we are looking for is under the square root. Then we are going to take the square of both sides to bring them out. So we now have 2 root 5 all squared equals to square root of 1 minus times minus is plus, so 1 plus 3 all squared plus y minus times minus plus, then plus 2 squared. Then we have another square outside because of the square of both sides. So the square here cancel the root. So 2 squared is 4. So we have 4 multiplied by square root of 5 squared is 5. So which is equals to, so we are left with bracket 1 plus 3, 4 squared plus y plus 2 squared. So that's what we have. Then next thing is to simplify further. 4 times 5 is 20 equals to 4 squared, that's 16, plus y plus 2 squared. So the next thing to do is to collect the like terms. So to collect the like terms, we are going to have 20 minus 16 equals y plus 2 squared. So y plus 2 squared. So 20 minus 16, that is 4. So we now have so we have 20 minus 16, that is 4, equals to y plus 2 squared. So we can write this as y plus 2 squared equals 4. So to bring this out of the square, we are going to take the square root of both sides. So we have square root of y plus 2 all squared equals to square root of 4. And once you take the square root of the constant, you are going to have plus or minus. So the power here we call the root. So we are left with y plus 2 equals plus or minus square root of 4, 2. So you can now collect the like, transfer 2 to the other side. So we have y equals minus 2 plus or minus 2. So y equals minus 2 plus 2, or y equals minus 2 minus 2. So therefore, y equals 0 or y equals minus 4. So these are the two values of y. So we can check whether our solving is correct by putting any of these values into the distance formula, whether we are going to have 2 root 5 as our answer. So that is that question number 2. So the question says, find the value of alpha squared plus beta squared if alpha plus beta equals 2 and the distance between the point 1 comma alpha and beta comma 1 is 3 units. So what we need to do here, we have alpha squared, we have to look for alpha squared plus beta squared, so which is unknown. Then we're given alpha plus beta, which is equals to 2. Then we are given point 1 comma alpha, which is our x1, y1, and beta comma 1, which is s2, y2. So what is the distance formula? The distance formula, d, equals square root of s2 minus s1 squared plus y2 minus y1 squared. So our aim is to get what? Alpha squared plus beta squared. So what is the distance given? The distance given is 3 units. So we have distance d to the 3, which is equals to square root of s2. S2 is beta minus s1. S1 is 1. Then we squared it. Then plus y2, that is 1 minus alpha, then squared. So the next thing to do is to, what we are looking for is under the square root. So we are going to square both sides to bring them out of the square root. So we are going to take the square of both sides, so which is 3 squared equals to square root of beta minus 1 squared plus 1 minus alpha squared, then we square all. So we now have square cancel the square root, so we are left with beta minus 1 squared plus 1 minus alpha squared equals to 3 squared is what? 9. So what's the next thing to do? We have to open this bracket, open this bracket. So we are going to have beta minus 1, then beta minus 1, then plus 1 minus alpha, 1 minus alpha equals 9. So what's the next thing to do? We must open the bracket. So we have beta multiplied by beta, that is beta squared. Then beta multiplied by minus 1, that's minus beta. Then minus 1 times beta, that's minus beta. Then minus 1 times minus 1, that's plus 1. So we are done with the first bracket. Then plus 1 multiplied by 1, that is 1. 1 multiplied by minus alpha, that's minus alpha. Minus alpha times 1, minus alpha. Then minus alpha times minus alpha plus alpha squared equals 9. So the next thing to do is to rearrange. We have alpha squared plus beta squared, alpha squared plus beta squared, then minus beta, that is minus 2 beta, then minus alpha, minus 2 alpha, 1 plus 1, that is plus 2, equals 9. So the next thing to do is to transfer this to the other side. So we have alpha squared plus beta squared, then the common factor here is minus 2. So we now have minus 2 into alpha plus beta. So by the time you open, it's as if you extract minus. So minus and minus, you are left with plus. Minus and minus, we are left with plus. Then plus 2 equals 9. So we now have alpha squared plus beta squared minus 2 alpha plus beta equals 9 minus 2. So we now have alpha squared plus beta squared minus 2 into, don't forget what we are given here. That is alpha plus beta is what? 2. So we are going to replace alpha plus beta with 2 equals to 9 minus 2, that is 7. So we now have alpha squared plus beta squared minus 4 equals 7. So alpha squared plus beta squared equals 7 plus 4. So alpha squared plus beta squared equals 11. So what we have to find is what? Alpha squared plus beta squared. So alpha squared plus beta squared is 11. So that is answer to question number 3. So thank you.